I'm going to go live now. This was unplanned and unscheduled, and want to give a little bit of a video update here, but this absolutely was not scheduled, and I just decided to do this as kind of the last moment. So what I've got here is, and pardon me for looking over here sometimes because I'm going to look to just see if anybody pops on. If you're watching this on YouTube, this was recorded much earlier. I do Facebook Lives, but this one was not scheduled at all. So I just dropped this in here, but I want to give an update. I'm not sure how good you can see it, and I'm going to pick the camera up here a couple of times and zoom in here. And hopefully, if you got any audio problems or can't hear me, let me know, because I got this cranked up pretty high, and it looks like it's working good. So this is the screw jack actuator for the rear cargo door on the cargo transport plane I'm designing. And I want to, and it's going to be kind of hard to see this on the camera, but I'll zoom in here in just a minute. But essentially what this is this is a 1/4-inch jack screw, lead screw, with a brass lead threaded knob on it. And I've got a DC 12-volt motor here. I've got some relays on here. And basically this right here is what I call the shuttle, and this is going to move. So what I'm going to do is fire this up right now. And hopefully it works. I've only tested it once, but I want to do some testing when I'm doing the video here. Now, a couple of things I'm doing here that people are going to give me some crap about, and I really don't care, is this is a 12-volt motor. And the load I'm putting on this is so small, and that I don't think I'm going to burn up the motor, okay? So the thing is if I did this at 12 volts, this takes almost 2 minutes to move the entire stroke. If I take it up to 22 volts, it takes about 45 seconds, which is acceptable. I haven't tested it above 22 volts yet, but it works really good. So basically, it's going to be really hard for you to see. Here, let me get the camera here, and I'll show it to you if I can get this off here good. So I'm going to see how well this works, everybody, okay? But right here is a little microcontroller, and this microcontroller was designed for me by Burger de la Pena. And basically what this does is it has right here, this wire here is what controls my motor. So it either goes DC plus or DC minus to reverse it. Right here is the receiver input that comes from my transmitter. And then right here are relay wires. And basically there's 3 wires for the relays. There's a common that runs the entire system, and then I've got 2 relays at each end. So this right here is my microcontroller. Here's my motor. Here's my thrust bearing. This isn't mounted yet, but this is what's going to go up against the thrust bearing so that there's no load put on the motor shaft. This is what I call the shuttle right here. This moves up and down the screw. Right here is a relay, and then all the way down here is a relay. And then right here is the end I made with a bearing that captures the end of the lead screw. So I'm going to put the camera back up here now. And hopefully you can see this. Now, you're going to notice when I first turn the receiver on, I'm not sure if you can see that red light, but there's a little red light here. And when I do this, you see that other light blink, then I do this and it blinks, and it means it's armed now. So I'm using my landing gear switch because this doesn't have retract. So they'll either be the cargo door open or the cargo door closed. So when I flip this switch, you see the shuttle start moving down the track here. And hopefully you can see that. I'm going to grab the camera again because I have no idea how good the video resolution is. So here's the shuttle right now moving down the track. And right now it takes 43 seconds Now it's moving around a little bit, and I don't care. When it finally gets mounted onto the two arms that's attached to the door, it'll be a little bit more stable. One thing that drove me nuts is the McMaster car lead screw had a little bit of a bend in it, but once it's attached to something, it's not going to matter. And if you notice, as this gets down to the end here, it's going to touch that relay, and it stops. So if I hit the landing gear switch the opposite direction, now it's going to run all the way back down. And if I try to hold this, I mean, it is real. Actually, it's moving the lead screw. I mean, it's really, really strong. I mean, it's really strong. And it will run all the way back down here. And then it hits this limit switch. And it stops. So right now this prototype has worked out really, really, really good. Make sure my camera's still working right. What are you calling relays or just micro limit switches, right? Yeah, I don't know why I'm calling it a relay. Yeah, that's wrong. I shouldn't be calling those relays. They're limit switches. It's been a long week with work, guys, and yeah, totally wrong terminology. Okay, look, I haven't had much time to spend this week on the hobby at all. I was up really, really late last night trying to solder all of this together and test it. I got up at 4 this morning to play with it. These are limit switches, not relays, and they're just basically open or closed. Now, one thing I'm going to do that's going to be really, really kick-ass is that I'm going to set another limit switch. I keep wanting to say relay. What the hell's wrong with me? I'm going to set another micro switch, limit switch on there. So when this is all the way open, which means my door is all the way closed, the lights inside the fuselage are actually going to be green. When the door is open all the way, all the LEDs inside the fuselage will go red. So if I'm flying by and I see green lights, I know that my door is not open all the way. If I see red lights, I know that it's hit the limit switch and it has gone all the way. So it's what you mean, not what you say. I know. But I'm really super totally excited how this turned out. The whole thing weighs less than 1.5 pounds right now, and which is about what I thought it would weigh. You know, I always want everything to weigh lighter than I can get it to go. So to kind of recap anybody who just showed up, and you can of course watch this video in full, I have a microcontroller that my buddy Berger designed, and it basically takes the receiver input to tell me to either be like if it's landing gear up or down, or if it's a door open or closed. The really cool thing is that it takes a nominal 5 volts in on the receiver side of it that will actuate the actual microprocessor, but on the motor driver side it will take up to 32 volts. And right now I'm putting 22 volts through to test it. If I run this 12 volt motor at 12 volts, it literally takes 1.5 minutes to cycle this. At 22.5 volts, it does it in 43 seconds, which is acceptable. I'm going to have this plane so overpowered, I think I'm going to get 15 to 18 minute flights. So if I take off and do one orbit around the field, open the door, takes 43 seconds for the door to open, great. I drop my cargo. Once I'm done with that, hit the switch, takes 43 seconds to close. I'm still not confident I'm not going to go above 22 volts because I can technically go up to 32 volts. But I don't know what this 12 volt motor, even though it has almost no load on it, what it's going to really behave like if I get up into the higher voltages. Because right now I'm running 22.5 through it. I've only cycled this about 3 times so far. And it is stronger than hell because I actually had, I didn't realize it, but I left one of my Allen drivers in the track here. And as this went down and hit it, it actually pulled the track apart. and which took an awful lot of force to pull that ABS apart. And but that's it right now. And it's slicker than snot. I mean, it is absolutely working great. So this wasn't a scheduled video. Apologize for just dropping in here out of nowhere and doing it. But I just wanted to show this off because I'm just super excited about it. And it's all 3D printed. Oh, another thing, I'm going to grab the camera again, is if I want to abort opening or closing the door, I can immediately just reverse it by hitting the switch. And until it hits a limit switch, it doesn't care. And I'm not sure how good that's showing up on the old camera here. Now, one thing I am going to do that I don't have on here right now, and this is out of pure paranoia. I can't talk this week. One thing I'm going to do is, over here I'm going to have some limit switches that are actually hooked up to the positive, it doesn't matter. It will open up, how do I say this? DC has a plus or minus, but when the motor's reversed, those are reversed, so it doesn't matter. But one of those two wires is going to be looped into two limit switches that are normally closed. The reason I'm going to do that is if for some reason, the way this controller works is it is a condition switch. So it doesn't look to see if a circuit's open or closed. It just looks to see if the condition closed. So if these limit switches are normally closed and I'm cycling this, when they open, it will also stop it, vice versa. So it's a condition mode. So what I'm nervous about, and I've only had this happen once with all the testing I've ever done with all the landing gear I designed, is that I end up with some noise. And I've actually added capacitors before to take that noise out of the DC side of it. But the thing is that if the noise happens, it confuses the microcontroller for the condition of where that switch is. And if it ever ran by the limit switch and it ran into the in here, this has enough torque that it's just going to probably destroy the whole end of this. So by having the two other limit switches that are hooked up to the motor power, if it runs by that and hits the second limit switch, it will actually open the circuit and kill the power to the motor. That way the motor can't overdrive and damage anything. So I hope that makes sense. One thing about doing these Facebook Lives, I know I didn't advertise this one tonight, but if you're on here and you have any questions, ask them. One reason I do this live is for people to ask questions, and I know some people sometimes might be embarrassed to ask silly questions, but there are zero silly questions. I want to also, one more time, I'm going to cycle this again. I want to show you something I'm pretty proud of, and it was this end right here where the bearing is, and I'm not sure how good you can see that, but I'm going to reverse the switch for a minute. And once this hits the limit switch, you know, I had the ABS against ABS as a bearing or a bushing, and ultimately it started melting the ABS. So I actually designed this with a ball bearing in there, and that will never wear out as long as it's in there. I hope that's showing up on the camera okay. But I was really, I know that's little and simple, but I got to be honest, I was pretty excited about how that turned out. So redundancy, yeah, absolutely. That's the reason I would have that secondary circuit on the limit switches, is for the redundancy. Because I just don't want... You know, I don't even know where my old testing was, but I tested this at 12 volts on this lead screw, and I was getting 65 pounds of thrust out of it. And 65 pounds will completely destroy this entire gadget if it ever overran past its limit. And the thing that is actually one of the hardest things to make right here, let me see, I'll grab the camera and show you. And this would break. This would be one of the weakest points. But right here, I made a 3D printed adapter to take the lead screw thread in, and then it fits on the shaft of the motor. And that's the reason I put these I got limit switch relay of the brain today, people. That's the reason I put these thrust bearings here, is so that there's no load actually. Hang on a minute, let me get that back on there. So this is a thrust bearing right here with the ball bearings, and then this will capture it and keep it. Whoops, sorry about that. I thought I had the camera on there better. So here we go. So right here is thrust bearings on both sides. This is a 3D printed adapter. And believe it or not, what's really cool is I 3D printed the threads in here, and I just really lightly had to take a tap, clean up those 3D printed threads in there, and that screwed right in there, absolutely perfect. And if you watch when I turn it, it's pretty square. I mean, that's pretty true. Make sure I don't jam anything here. So, well, that's all I wanted to do on this video, was kind of show off what's going on with this gadget that's going to open and close the rear door on the transport plane. So on this red thing here, I keep calling the shuttle, there's 2 holes for 632 bolts, and there's going to be 2 arms. I'm trying to think of the orientation here. Actually, the door goes like this, so there'll be 2 arms that come up off of this about 6 inches long, and as this goes down, it's going to drive that door down, and they will hinge on these 2 points right here. I hope later tonight to design those arms and get them printed, and then maybe tomorrow night get the door actually actuating. Dumb donkey me would have removed some thread near the end of the travel. Your way works best. You know, I thought about trying to remove the thread at the end, but this is hardened steel, and for me to get it down small enough and then have it, I guess the word is square or perfect enough machine that it would fit into my adapter, was just a big pain in the butt. Plus, I would lose about 1.5 inches of stroke on each end if I were to move threads. I thought of doing that. It's just, it ends up adding 4 inches to the length for me to do that. And, you know, I just don't have the distance to do it. So, hope all of this makes sense. I hope that, oh, another thing is this is 1/4 inch and this is 3/8 inch. This is about 105% more heavy than that. And this is what I've used on some of the big scale landing gear I built. And when I put this on a 24 volt motor, I got 165 pounds of thrust. And when I build big landing gear one day for massive airplanes, this will be the side of lead screw I use instead of this light 1/4 inch stuff. And this is very, very true. This stuff actually came bent a little bit, and I spent forever trying to straighten it up. So I hope that answers all your questions. I hope you understand what I'm doing. With any luck tomorrow night, I'll do a video with the actual door being actuated, but I just got a lot of things to get figured out geometry-wise on the length of these arms and what that attachment plate to the door is going to be. Thanks for watching the videos. If you've got any questions, send me an email, send me a private message through Facebook. If you're watching this on YouTube, I'm doing Facebook Lives. I'm not going to ever, well, I shouldn't say that because I hate using the word never and ever. I doubt I'll ever do anything live on YouTube because there's too many people out there that have screen names of Jack the Ripper and stuff like that. I'm sorry. If you're going to be anonymous, I'm not. There's too many trolls that hide behind stupid names. Thanks for watching my videos, everybody. And I will see you tomorrow night with the fingers crossed. So have a fabulous night and take care. See you, everybody. Bye-bye.